Hello everyone, welcome back to another tutorial. In this tutorial, we are going to discuss about the unit step signal. I will try to plot it in continuous and discrete domain by applying advanced visualization techniques. So first of all, let us discuss what is a unit step signal. So by definition, when we talk about the unit step signal starts from the zero and above for positive time for up to infinity it should not be infinity because it will not be then binded. It will not be a stable system. We will discuss about the properties of a signal, what should be the properties of a linear time invariant signal. So at that point we will discuss about the what are the linear signal and what is the purpose and the role of time invariant and variant signals. So when we did normally we apply our operations on the LTI systems and LTI signals. For linear time invariant signals, our signal should be based on the binded input and binded output. In only in that case it will be stable system. So when I talk about the binded input and binded output, so to keep it very simple for you guys, the bounded input means your time. If it is a continuous time signal, then the time should not reach infinity. It should be below than infinity, a very specific time, a very specific number of samples if we are in discrete signals. And for the binded output, uh, the binded output uh, defines that, or it reflects that your signal's output should not be infinity. It should be a countable number, it should be a reasonable number. So that's why when we talk about t less than 0, our signal should be 0 in the case of unit step signal, and if the time is greater than or equal to 0, then its value should be 1. By definition, an ideal unit step signal is just like that. So in today's tutorial I will try to visualize this signal in a very detailed way. In our previous video I briefly talked about the uh, unit step signal, but today I am going to show you uh, how we can visualize it in MATLAB and how we can make it in MATLAB. So first thing first, CLC, clear all and close all. So if you are not familiar with these operations of MATLAB, you should watch my previous videos. But if you are new to my channel, uh, for your purpose, CLC used to clear command window. Clear all is used to clear workspace. It clears all the stored variables, and close all is used to close all the existing MATLAB tabs if you have any. And then, so let me, if we are talking about a continuous time signal, so I am commenting here for only for your convenience, continuous time unit step. Okay, fine. Since it is a continuous time signal, so I have to define time. I will take my time from minus 10 to 10 with the step size of 1. I will keep this time from minus 10 to 10 throughout this course because it is easy to visualize our signals on only on these bases. So when I initialize this variable time and it has this row vector in it, we usually call it array. So this array, what does actually means by this array? So when we reach here in our graph, it tells us that the signal will start from minus 10, and from 0 to 10 it should be 1. So I am defining the timeline here, I am defining the timestamp for this purpose here. So from minus 10 to 10, now I am going to write about the signal attributes. So I have initialized a variable signal. In this signal, from the graph we can see that from minus 10 to 0 this signal's value should be 0, and from 0 to 10 this signal's value should be 1. So for that purpose it is a better approach if I initialize zeros vector. 1 cross 11 should be the dimension of that vector. I am quoting the word vector here because if a matrix has a length of 1 cross n, then it is called row vector. And if any matrix has the length of m cross 1, then it is called column matrix. I hope that you are familiar with the matrix terminologies. So now here I am going to define it. Zeros 1 comma 11. So I am writing here 11 because my total number of sample is 21 minus 10 to 10, it will including 0. So our signal needs to start from greater than or equal to 0. So for that purpose we have to define 11 elements, minus 10, minus 9 and up to 1. These are the 11 elements. So from next I am going to define, this is basically an array within an array. I will show you ones 1 comma 10. So braces close. So collectively in this signal variable I have initialized an array which is based on the a smaller array of zeros and ones. These two types of vectors are merged here. So let me run it. So when I run this command here, you can see that total 21 elements are available here, and the first few numbers are zeros and the next ones are ones. So I can simply plot this y-axis with respect to this x-axis. So let me plot it. Since I'm going to talk about the continuous and discrete time plots, so I will start from subplot approach, then I will move to the hold on approach as I did in my last tutorial. So for the subplot purposes I have to define the function of subplot. Since I will be dealing with two graphs, so it is a better approach to have two rows, one column, and at the first position I will plot this signal. So time comma signal. So now I want to have a discrete in it, so I will initialize another variable sample, which will have minus 10 to 10 samples. And then you can use the variable time because it has also same values, but just for your convenience I am initializing another variable sample, because in discrete signals we have only samples, we do not have time in those. So zeros 1 comma 11 and ones 1 comma 10, and the braces close, our matrix vector is completed. And then I will initialize subplot, two rows one column second position, and then I will stem this because stem command is used for the discrete visualizations, and sample comma disk. So let me run this code. Hopefully it will not have any kind of errors in it. So if any error came, we can simply deal with it. So now from this you can see that we do not know what is the title, what are the values of axis, what is y-axis, what is this above graph representing, and what is the meaning of this lower graph. So to make it more better, it is always better to have visualize, uh, it is always better to add title to your chart and add labels to your axes. So let me add those axes here. This was my mistake, I should have added it earlier. So continuous time unit step, okay fine. Just to save time, I want to give you an idea about it. Time, and okay, this is not tim, it's time. And y label, okay, y label, and here I am going to amp, okay fine, amp, it will be better. So let me copy this and paste it here, and this is discrete time, and these are the discrete unit step signal, and these are the samples here. Okay fine, okay fine. So also let me change its color as well. So for to change the color, you need to attribute another, you need to add another attribute in the stem command or plot command. You can use anyone you want. MATLAB has different kind of colors. I will make another videos on how you can detail your charts as well, because visualization in MATLAB is itself a very big and major attribute or feature of the MATLAB. So to keep things simple, just let me run this. Hopefully it will work, it will not have any kind of errors. There is a possibility. Okay, fine. Oh, fantastic. So here we have a continuous time unit step signal, discrete time unit step signal. It has time on the x-axis, it has samples on the x-axis, and both have amplitude on the this axis. So by definition, when we talk about its definition, it told us that the our signal should be 1 at 0, and all the greater values above than 0 should be 1. So when I visualize this graph, I came to know that my signal is becoming 1 at the very first sample. So this is a mistake. So let me correct it. I will just go to my this array, and I will reduce the number of zeros, because by mistakenly I included an extra 0 in it. So let me rerun it, no problem, no worries. So now by definition this signal is correct. So our signal is giving the value of 1 at 0, at 1 of 1, and 1 at this sample is equal to 2. So by definition it's correct. For time less than 0 our signal is 0, for time greater than 1 is continuously 1. So it is a perfect unit step signal. You can match it as well with your by definition signal. So okay, fine, good. Let me include some extra things in it. Let me include figure command, and I want to hold on this because I want to check those, and hold off. Okay, fine. So for that purpose I will copy this command plot, and also I will copy this command stem here, and I will copy the title and its other things here, and unit step signal. Okay, fine. Okay, an additional thing which we can perform in it is grid on. Grid on basically is used for the to open the grid in the our charts. So in our previous video we checked about the legend command, and legend command basically works in a sequence. So I will initialize the legend continuous step. Okay, fine, this closed, and discrete. Do not forget to add these commas, these are very important, and discrete step. So let me run it. Now we will have two figures. In one figure we will observe the subplot attributes, and in other figure we will discuss about the hold on. So let me run it. Okay, let's pray. Okay, fine, there is an error. So the error is saying the grid on, error is in grid on command. So let me check. I think it is showing that the closest match is grid in grid. So the in library the g is the g is smaller. I by mistaken I included the capital G. And where is this error present? Error in exponential underscore signal file. This is the name of my file. I used the same file for my previous exponential signals video. That's why I have not renamed it. I am just editing in that file. So you can simply go to this error by just clicking on this line 33. So I have write it in smaller caps. Now let me run it. Let's pray that there is no error. Okay, fine. Okay, now we have two figures here. You can see that pattern for both figures is same. Our signal is behaving very well. At 0 its amplitude is 1, at 0th sample is amplitude 1. But when I specifically talk about this, the hold on command with legend, it is a very great MATLAB feature which allow us to visualize our charts in a more appropriate way. So you can see that in both continuous time and discrete time signals, our signal had the value 1 at time is equal to 0 or samples is equal to 0. So for the rest of that our signal was 0. Unit step signals are very important. I will, once I am done with the MATLAB series, I will include a theoretical concept about the signal and systems. So in those concepts, most probably I will be discussing about the in-depth role of unit step and unit impulse signals. What is the purpose of these signals? So just leave it for the another day. Hopefully you would have liked this tutorial. If you want to make me another tutorials like this, just simply subscribe, comment, and like my YouTube channel. Hopefully, you will like it. Thank you so much for watching.